Hello everybody, my name is Jung-Hye from University of Wisconsin. Today we present our study, Home is Where We Age, developing a research method for studying home environments using 3D scanning, wearable technology, and accessibility scores. Presenting with me today is my colleague Yu Hong, and there are two other collaborators who's not here with us today, including Kevin Ponto and Ross Tredinick. Let me provide the study background on aging in place. By 2035, a third of American households will be headed by someone aged 65 or older, and 40% of them will have one or more disabilities. Baby boomers prefer to age in place even when their health and their functional abilities decline and their safety is compromised. Yet only 1% of American homes offer features necessary to accommodate this desire. This mismatch poses looming public health challenges, but research on interior home environments for older adults is scant. In this context, home modification became an important tool to address issues of aging in place. Home modification is currently conceptualized as a targeted medical intervention in the field of occupational therapy in order to make up the deficiency of a home environment in support of individuals' disability. We question this medical approach and urge the design professionals to have an ownership of this issue and to address the root cause of housing failure by seeing it as a public health issue. To this end, we need to provide more research evidences, innovations in housing policy, provision of design guidelines, innovative design education, and we consider our study as the first small step toward it. Our research goals include, first and foremost, identify, document, and visualize common barriers to everyday activities at home, ways in which the home modification addresses these issues, and how older adults navigate these spaces. Subsequently, we did hypothesis testing. Home modification increases housing accessibility, functional independence, and satisfaction. It increases psychological well-being. It reduces the duration of sedentary behavior and incidences of acute stress responses.
The methods that we took to try to answer our research question include the use of several devices to track participants' location, movements, activities, biomarkers, functional independence, and life satisfaction for a period of 24 to 48 hours before and after the home modifications. We used the devices that you see here to track the participant's location, movements, activities, and biomarkers. The wristband is called E4 and measures the participant's biomarkers for 48 hours. The device in the middle is a camera that takes 360-degree photos and is called RICO. The white device on the right is called Narrative and takes pictures of whatever is in front of the participant, and they would wear for 24 hours. These figures show an example of what the data from the multiple devices would look like after they have been cleaned and overlaid together. I would like to draw your attention to the bottom graph first. The raw data at the bottom graph is 3-axis accelerometer data. The green, blue, and red lines indicate 3 different axes, and the purple is combined with activity levels. The top graph shows the data from the wristband and the wearable camera. The blue line is the E4 data and the yellow line is data from the wearable camera, also known as the narrative. When overlaid together, it became clear that delta value 4 is a valid cutoff line between being seated and standing. Thus, we consider any period over the delta value of 4 as non-sedentary and under 4 as sedentary. We calculated proportion of wake hours under 4 as a sedentary behavior indicator. This slide shows the scanning device that we use to obtain 3D images of the participant's home. The image on the left is a photo of the 3D LiDAR scanner. The center image depicts the angles at which the device can capture from a single view, and the right diagram shows how a 3D coordinate is calculated from 2 angles and the measured distance. We also collected other information such as their basic demographic information. We used other assessments such as the IHOPE or the in-home occupational performance evaluation to assess the participants' activities. We also used an assessment form called Housing Enabler to assess the participant's house and look for their accessibility of the home. And then we also use Riff's psychological well-being scale, created by Carol Riff. All of the scales have been highly validated through multiple studies. This is an example of the data fusion and visualization from all of the data that we collected from each participant. This is an example of one participant's situation. So this participant lived in a typical suburban house. His car is parked near the front entrance so that he can use the ramp to enter through the front entrance rather than the back, because the back has stairs, which makes it really hard for him. Because of his physical limitation, he spends a lot of time inside the home near the entryway, in the computer room in the back, and in the kitchen, but he does have trouble using the stairs. On the main floor, he uses his walking sticks to go throughout the different rooms, but when he has to go upstairs, which is where his bedroom and main bathroom are, he leaves the walking sticks by the bottom of the stairs and would walk up the stairs very slowly, taking one step at a time, while grabbing on to the railings on both sides. So this is the upper story of that previous participant's house, and as soon as he gets up the stairs, he would transition to a walker. The walker is always parked up there waiting for him so that he can easily go from grabbing onto the railing to using the walker. While upstairs, he always has the walker with him at all times. This slide shows the modifications that we did for this participant. The image on the left, you'll see that the railing interrupts along the wall, which is on the bottom of the image. So the one on the right, you'll see a continuation of the railing, which is what we added for the participant. This slide shows a video example of the participant and an activity that he would usually do, which is going from his study room to upstairs. Notice the time and location on the top and upper left. The use of technology in this study allowed us to track the activities that the participants do throughout the measurement period. As a result, we were able to collect data related to the time and location of the activity, as well as how the body reacts to the activity. The bars on the left side show the heart rate, the body temperature, and the stress level of the participant as they are doing the activity. These data are synced with the time and activity so that when the participant moves, the bars show the body's reaction and also changes accordingly. In this video, these bars actually don't move, but it gives you an idea of what will happen. Currently, GPS tracking is usually used for outdoors, but it does not work for the indoor tracking. So our study has been able to achieve something similar to this with the use of multiple tracking devices. Here is a video of the same participant from his living room going upstairs to his bedroom. The only difference is that this video shows the continuous railing, which is the modification that we did for this participant. This is another example of a different participant who lives in an apartment complex. The image on the left is what the whole building looks like, including the sidewalk around the complex. The front entrance only has stairs, so this participant is forced to use the back door, which goes right into the bedroom of his apartment. By doing this, he has to go around the entire building so that he can use the paved sidewalks. The second image shows how he has narrowed down his life space to the couch, the kitchen, and using the back door. This slide shows some of the modifications that were completed for this participant's bathroom, as well as the data that we collected during the measurement period. Again, notice the time and location on the upper left corner and his biomarkers on the bar graph on the left. The image on the right shows the modifications that we did, including increasing the toilet height from 15-inch to 17-inch, multiple grab bars added or adjusted in the back, a shower head that allows him to shower while being seated, the addition of a toilet paper holder which does not require him to twist his torso when grabbing the paper, and the whole body mirror, which was not captured in this image. I want to highlight the narrative that he shared with us about his activity of using the new toilet. He said the new height of the toilet was just the right height for him to easily transfer from his wheelchair to sitting on the toilet. Before getting the new toilet, he would have to get up from his wheelchair and then sit down on the toilet, which is a lot lower, so it was much harder for his body.
This slide shows the demographics of the participants in the study. We were originally planning to recruit 30 participants. However, at the time of COVID-19 shutdown in mid-March, we were able to recruit 24 participants, completed 20 pre-tests, and 8 post-tests. Included in this presentation are information from 8 participants. Their average age was 72.38. Income levels differed widely. There were 6 males and 3 females, and they all lived in different kinds of homes, including single detached houses, rental apartments, and condominium units specifically designed for aging in place. So with the completed data set, we proceeded with a series of hypothesis testing. Our first hypothesis was home modification increases housing accessibility, functional independence, and satisfaction in conducting everyday activities. To test this hypothesis, we used a paired samples t-test comparing pre- and post-test conditions of home accessibility. We did this testing to demonstrate a variety of potential uses of the combined data set rather than generalization. We used 2 different scales in assessing home accessibility. The first one is in-home occupational performance evaluation. The result shows that our intervention increased home accessibility and the result was statistically significant. The performance score rose a little bit, but the result was not statistically significant. The second scale, called housing intervaller, shows that our intervention reduced various scores mostly around the indoor and bathroom areas in particular, revealing that those are the areas where most participants struggled and wanted to change. Our second and third hypotheses are home modification increases psychological well-being and reduces duration of sedentary behavior. Our statistical testing using the paired samples t-test shows that the home modification does not influence psychological well-being nor sedentary behavior. Our fourth hypothesis is home modification reduces incidences of acute stress responses while conducting daily activities. For this hypothesis testing, we considered using several stress indicators such as heart rate variability, electrodermal activity, but settled down with the heart rate for various reasons, particularly focusing on the correlation between heart rate and movement. The graph shows the result from 8 participants, where blue dots show pre-test results and orange dots show post-test results. Vertical axis shows heart rate and horizontal axis shows activity levels. You can see that for some participants, such as 2, 3, 11, 13, their heart rate has not changed at all, but in 5, 7, 9, 10, the heart rate has been dropped, especially during the slow movement. So all in all, our study shows that home modification has a potential to improve home accessibility and functional independence of the residents, but such improvements do not necessarily lead to a satisfaction and psychological well-being. And there could be many other reasons, but we think the small sample size contributed to that end, but also rapid health decline that we observed amongst about a third of our participants. We'd like to also point out that the acute stress response requires further analysis. In conclusion, our study shows highly detailed and accurate documentation of the supportiveness and accessibility of the current housing stock and evaluation of modifications made in response to various health and housing issues in aging. It also serves as a good proof of concept for our long-term goal of building a publicly available database, which allows designers, students, and researchers to study and explore household environments and further develop solutions based on real-life scenarios. It could also be developed as a teaching tool and test its effectiveness in increasing sensitivity amongst architecture and design students. The study also has weaknesses, which include large data set that requires heavy resource investment and time-intensive data analysis, small sample size, and limit of home modification, which may have limited the effect of our intervention. So that concludes our study, and thank you for listening.